And I'm sorry, but that's the most offensive thing that I've ever said in class. My bad. Sweet. So we are solving some systems. Now, what's cool about just shoving these two together is I'm not going to tell you whether we're doing elimination or substitution. Realistically, does it matter which one you pick? No, they'll both work, right? Now, normally one of them is easier than the other, but they will most definitely both work. I don't have any problems in front of me. So we want a gross one, huh? Let's do it. How gross can we make it? Okay, so here we go. We're going to do some examples. And again, we're going to have to decide whether this is elimination or substitution and come to a conclusion and carry on through it. So I will write the problem here. I'm going to give you guys like a minute or so head start. Then I'm going to start calling and asking for your guys' input on what do we write. So solve each system. And here we go. For our first one, I want us to solve a nonlinear system. Nothing crazy, but here we go. Our first equation is 3x squared minus 2x plus y. And I'm told that that is equal to 0. My second equation is in this wonderful standard form, negative x plus y equals negative 2. Okay. Do not graph this. You don't need to. You could if you wanted to, but you're not going to trust your graph anyway. I'm going to give you guys a 60-second head start. You're welcome to chat stuff. I'm going to start calling on people in about 60 seconds, though, for methods. Cool. Talk it out. 60 seconds. Voila. I think it's Addison or Wisha. How would you be number with a W? Weird. I have no idea how the number shook out in here then. Who's 12? Could be Basil. Who's 8? 8. What would you like me to do? How do you want to approach this problem? Okay, so are you giving me elimination or substitution? Good. And if you're not sure, when you said to cancel out y, if you just change it to eliminate y, that's it. Now, when I do substitution elimination, I have a very specific notation that I use. You may remember doing this in algebra or geometry with me a couple years ago. I don't know exactly how you guys did it last year, but check it out. You said multiply the bottom equation by what? Do I need to touch the top equation? So if we don't need to change the top equation, it's like me multiplying it by what? 1. Now, when I do this, this is everything multiplies by 1, right? Like all of these, left and right side of the equation. So this doesn't change anything, which is fine. And I very specifically, I do use this arrow notation every single time I do it. So this one doesn't change. 3x squared minus 2x plus y. Still equals 0. If we want to eliminate, you said, are we eliminating y or x? Okay, so if we're eliminating y, if you don't recall, I'm just going to add these two things together. That's what happens once we rewrite this. What would you want me to multiply both sides by? Yep. If I multiply everything by negative 1, Red, what would this give me? X minus y equals 2. The second that I do that, even though it's nonlinear, it's the exact same thing that we've been doing. We might just get some more answers. What do I do with these two equations? I'm going to add them straight down. And notice I put the x over the x and the y over the y very intentionally. 3x squared plus no more x squared is still 3x squared. Negative x, or sorry, negative 2x plus x. Y plus a negative y. I'm not even going to write it. And 0 plus 2. We now have a wonderful equation here. Okay, so what? I can solve this. Now, I saw calculus making a really goofy mistake here earlier, so I want to really stress this part. I need to solve this equation. In other words, I need to find the solution to this equation. Why am I stressing the word solution so hardcore here? It's a quadratic, and I'm trying to find the solution. What are some other words that I want you to be thinking of like every time? Roots, zeros. What do I set this equal to solve it? 0. Let's set it equal to 0. What do you want me to move? We should negative 2. So I'll subtract 2 from each side. So now that we're here, let's just solve for x. 3x squared minus x minus 2. Kind of embarrassing, but I have forgotten how to factor. It's like I might have to do a factor quiz or something. Everybody needs to know how to factor. I cannot stress it enough. If you do not know how to factor, you should come and talk to me to get help factoring. Okay, I can hear Lay, and I love it. She said 3 times negative 2 gives me, now what? They multiply to negative 6, but they add to negative 1. Now, I run through this in my head every single time as follows. And you don't have to write them all if you're quick about this, but it could be 1 and 6. And I hate that 1. Now, if it's 1 and 6, and one of them has to be negative, which one would have to be negative if we needed them to add up to a negative? 6. So we could do that, right? It's not those. What do they add up to? Gosh, that's not negative 1. Bummer. Give me another way to get to negative 6 then. A positive 2 and a negative 3. What do those add up to? Hey, that's what I need. What do I use these for? So careful. I heard put it into x plus 2 and x minus 3. Love the idea, but I hate the application here. Can anybody tell me why I don't like the application of just calling this x plus 2, x minus 3? What's the leading coefficient here? Wisha, you wanted it to be a what if you're going to use that rule that you just tried to use? If it has a 1, you have a shortcut. If it doesn't, you don't. So what do I use these magic numbers for? I'm going to rewrite it, and we're just going to replace. So let's just rewrite this whole thing. 3x squared, and I'm going to leave some awkward gaps here, or I'll switch colors, plus 2x, or you can do minus 3 if you want, plus negative 3x minus 2. I would encourage you to. You should switch yours. I'm like, it doesn't really matter. It doesn't matter at all the order they come in. Normally, I do put the negative first, but if that's not natural for you guys, I wanted to make sure that we're okay, that adding a negative is the same. If I don't change mine and you don't change yours, we should get the same thing, even if we do it differently. I want you to try it your way, or the other way with the nicers. Okay. You say do this, right? Yep, and I would encourage you should do it and solve this problem. Just verify we get the same thing. Yep. Okay, well now what? X comes out of this. Abijah, what stays behind if I factor an X out of these two? All right. Davian, I need to leave a 3X plus 2 in here. What should I factor out? Negative 1. It leaves a 3X plus 2. Now, because we're just trying to look for the solutions, do I really care if you write this in one more line as factored completely? Is our goal here to factor or just to solve this? Can you tell me what the factors are without writing the next line? So you've given me the roots, but I'll take that. You can give me the roots, you can give me the factors. If you needed the factors, or if you're stuck on this factoring, check it out. Those match. There's a factor. And this is optional. If you can do the other part, that and that come together to make our other factor. Okay. When we have this, you guys gave me the roots or the solutions, and you said it was at x equals what? Negative 2/3, and that's by setting this factor equal to 0. Subtract 2, divide by 3. And what about this one? 1. Are we done? Why not? How on earth are we going to get the y values out of this? Plug them in. Now, where could I plug them in? And I'm going to put some big blades of grass on the screen because that makes sense, of course. Where would you plug this in if you wanted? So I'm just here in the middle. You guys direct me where to go, and I'll plant some grass here. And we'll make it green so it's grassy colored. Where could I plug in these x's to get my y? Tell me, where should I physically move my cursor? Left. Up. Can we plug it in there? We could. Redmond doesn't want to. Why not? Yeah, this is so much nicer. Can we plug it in here instead? Okay, any of them will work. This is probably the one that, I don't know, maybe this one? Well, let's just plug it in. I want you to plug in negative 2/3 and plug in 1. and I want you to give me the x values, sorry, the y values that you get from there. Nope, I got to change back to not grass. Find me the y values that correspond to each of these. Order matters, big time. Oh, I'm goofy somewhere. Am I goofy? Well, that's what I'm looking for. Where did I get it? It's 2/3. Why did it change to 8/3? I can tell you exactly why it happened. What does this combine to be once I do the right stuff? I was a step ahead. I get -8/3. Do you guys agree? Now notice, and I want you to very specifically notice this. I checked the first x that I had written. I wrote the first y. The order matters. We need them to correspond. When I go to write my actual solution, and I'm going to be crazy about these, they have to match. What about for 1? This one's easier. Can I get a second on -1? Cool. Is there anybody who's not sure why -1 or how it happened? So did you plug into this one here, Edison? Okay, and whichever one. If we plug into this one, if we just rearrange this, and I don't know if you would rearrange it first or after, could I add y and subtract 2? So that I could have the expression that says y equals, let's see, add y and subtract 2, x minus 2. And then what do we just find for our first x? So it could be 1, whichever one you wrote first. Mine is -2/3 first. So when I do this, I'm just going to say y is -2/3 minus 2, and we're going to get -8/3. Okay. And then same thing happens with 1. Did you do mental math, or don't erase it yet? I'll come look. Okay. Okay, too late. Okay, here's the part where I'm crazy. Am I a stickler for notation stuff? Have I ever counted you wrong because your notation wasn't what we agreed it should be? Definitely. I guarantee I've counted most of you guys wrong for something that you probably thought I robbed a point for, because I'm crazy. What do these actually represent? They're coordinates. Right now, do they look like points on a graph? No, but we could make them points. Now, we should probably check them. We really should. Let's check them. One of these, what was one of the ordered pairs that we just found? 1, -1. When I check my answers, it should make this true. Let's try. If I plug in a 1 for x, I get 3 minus 2 is 1, and I'm plugging a -1 in for that. 1 minus or plus 1 is, oh my gosh, 1 minus 1. There we go. That one checks. What if we plug in a 1 and a -1 here? 1 minus -1 is 2. It checks. Could we do it with the other one too? It's a little uglier because they're fractions. Same thing. Do you think it's going to work? So I assure you it will. I would, on a test, you can't just assure me. You need to actually check. I don't have to see it. You can check it on a calculator. I'm fine with that. What's my other order pair, though? And I hate the way that I wrote that fraction. This is the only time you'll ever see me write these fractions, because I guarantee there's no x or multiplying that has to happen. Okay. If you wanted to, and there will be situations where whether you want to or not, you're going to need to. Do you want to try one more? I want you to try one more. I'm going to give you 2 minutes to try this, and then we're going to talk. Okay, second one. I want you guys to solve this wonderful system. We have 2 equations. The first one is y is equal to the natural log of x. I can tell you're excited about this. And the other one is x plus y equals 1. And I said 2 minutes, but I lied right to your faces. I'm going to give you 60 seconds. So this might be like old school, and I would never write this again. Okay, I'll probably write this again next year if you guys forget it. But I just want to make sure that we're on the same page. I'm going to do some thinking here. Y equals, and I hate doing this, and it drives me crazy. Is this the same thing? And I despise it, but it is. What's the base of that logarithm? So here's our base, and then how do logs work? It's e to the what power? To the y. Equals what? So if we wanted to, and I'm going to use this little idea, we could have e to the y equals x. This is just a rewritten form of this. It's not going to hurt. Now, do we have substitution or elimination waiting for us, Karina? We made eye contact there for a second. You sound incredibly confident. Why substitution? Yeah, it's already done for substitution. You could try to eliminate, but it's not going to be nice. Okay, we might run into an issue. This gives me e to the y, because I'm just plugging it in here, plus y equals what? Anybody know how to solve something with a y both in the exponent and not in the exponent? So if we take the natural log, I like that idea, but the natural log of a sum does not work out nicely. If you have a product, you can rewrite it as the natural log of x plus the natural log of something, but you can't do the natural log of a sum. There's no rule for this, which means we are beyond our capability. So fun fact, logs are known as transcendental functions, and to transcend means what, Karina? Good. We have transcended our understanding of the transcendental functions here, and we can't solve this yet. Well, man, if I can't solve this, it means I'm completely burned. If only we lived at a time in human history and civilization where we had like this unbelievably powerful tool in my bag, on my desk. Oh, my calculator. Okay, grab a calculator. Let's look at something. I have leaned away from using the calculators super heavily this year because I don't care what your calculator can do. I care what you can do. But there are some times where I need you to be able to tell your calculator what to do, and this is one of those times. Remind me again, and I'm going to check this before we type stuff in. I want you to try to sketch these functions. Do not graph them. 10 seconds. What do you think ln x looks like? What do you think x plus y equals 1 looks like? Sketch it on your margin real quick. Like somewhere on your page. Physically sketch it. I'm going to come be judgy. I'm going to give you a love it or hate it. There's no in between. I can sound mean about it if you want. What do those two graphs on the same coordinate plane look like? Don't think it out. Just go with your gut. Just say what does your brain think right now? Hate it. Which one's that? What? Is that the log or is that the? Yeah, this is my thing. I don't know. Okay. What's the log and inverse of? What do exponentials look like? Everybody, can you show me just like, we'll start here, we'll go, help me figure out what exponentials look like. It does that, right? It's like growth. If you were to flip this, because logs and exponentials are inverses, there's an exponential. What do they flip over between a function and its inverse? There's some really nice reflection line. Y equals x. That's what logs look like. Cool. Do you think you guys might have to graph a log again? Yeah. Bet, bruz. Sorry, chat. All right, check it out. That is what the graph looks like. Now, for this, if we were to just graph this, and I'll graph it on Desmos for us even, ln x, hey, it's already open, and I will not steal that one. One of them is natural log of x, and the other one, how do you graph x plus y equals 1? How many of you guys would change it to y equals negative x plus 1? I want to remind you there's a better way. Like that one's not bad that way. When x is 0, what would y be if you have x plus y equals 1? When x is 0, y is 1. What about when y is 0? And if I'm losing you, and this is like old review stuff, this is just me thinking out loud, because I want to think about the graph. If x plus y equals 1, let's just think. If x is 0, what y does it spit out? 1. And if y is 0, what x does it spit out? How many points do we need to draw a line? Do we have 2 points? If my natural log graph, and I'm just going to graph them both here, and then we'll look at Desmos. If this is what the graph of ln x does, I just need 1 and 1. I can draw a line through them. There's what our graphs look like. Now, for this, if we don't remember the library of parent functions, which I'm pretty sure is section 3.4 in your notes, thinking back to it, you need to know them. We might have to take a break because seemingly this is boring right now. We're going to finish this first, though. Okay, looking at my graph, where do you think it is? Where do you think the solution to this system of equations is? So like you can point to it, and I assume we're all pointing to this. It looks like 1, 0. If this were 1.00001, comma 0, would we be any the wiser? We would have no idea. Can your calculators also do this? Does everybody have a calculator in front of them? Okay, grab your calculators. This is one of the few situations, and I'm going to be honest, this is how I would check my answers if I had a calculator. Half the AP test this year is not calculator, though. Like, you can't use calculator on half of it. Okay, as we're going through, I have a calculator in front of me. If I want to graph these functions, how do we do that? And I don't want you to see my word problems that we're about to do either. How on earth do I put these functions into my calculator? I'm going to throw some shade. I know a bunch of you guys did it last year because I saw you graphing on a calculator and then tracing the graphs to what you thought it should be. So I know you guys know how to graph on these at least. Oh, y equals? Okay. What's their graphs? ln x. Where's ln? Okay. So bottom, kitty corner from 4, right? ln of x. Okay, put your parenthesis. What's our second function? X plus y equals 1. I cannot type that one in. ln, is that what you're looking for? Next to 4. Y equals negative x plus 1 is the other one, right? Negative x plus 1. Okay, do we all have these stored in y1 and y2? Okay, I don't think we've graphed a single function on our calculator this year, have we? I don't think we have either, which is pretty awesome. Anybody not remember how to do this? I guess now you do, if not. Okay, so Leigh, I have the sneaking suspicion that you already graphed it. Here's what I would advise. You're okay to already graph it. Before I hit graph, if my scale is garbage, it's going to be garbage. How do I fix my scale before I even graph it? You can go to Zoom, and I have a suggestion. Standard is my go-to. That is my 10 to 10. That's what I'll normally use. It's like the most accepted. You can either scroll down to 6 and hit enter, or I can physically just hit number 6. It's going to put this standard, and it says invalid dimensions. What did I do wrong? Negative x plus 1. Yours probably does not say invalid dimensions, which makes me think that something weird is turned on, and it's going to be that one. Okay, so I'm just going to do the same thing. I'm going to go zoom 6. Standard. Does that look like ln x? Does that look like the line that I drew? Okay. Now, we could zoom in if we wanted, but we're not just going to trust the graph. If we look at this, what does this say above trace? Trace is one of the buttons up here. What's above it? And that's short for what? Calculate. I was expecting calculus. I was going to give you a hard time. I hit second, calculate. What do you think we're looking for? Are we looking for the value of a function? Are we looking for the zeros of a function? Are we looking for the minimum, the maximum, the intersect? We're looking for the intersect. If I don't want to scroll down to 5, what's my other option? I just press 5. Okay. Everybody should have this on your screen. It goes back. Do we all have this on our screen? Is your calculator right now asking you first curve? Okay. Leigh, do you have first curve on yours? Okay, this part's really important. If you're zoning out because calculator stuff's boring, I would zone in. We are choosing this function. It's just saying, do you want the first function to be y1? Yeah, I do, calculator. Yes. And then say, are you sure? Okay, yeah, I'm sure. Okay. So I have it. Sorry, I'm still sure. Why I hit enter, nothing changed. If I hit up or down, notice it changed. And I don't know why it's saying first curve and second curve. Is yours doing the same stuff? Well, that's what I did before, but it didn't do it. So I'm going to go back up here, enter, 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 enter. Second, memory, 712. I'm going to steal somebody's calculator. That's got a weird setting stored in it right now. Okay, we're going to back up from that one, but I agree with you. Okay, intersect is 5. I have it. Now, if I move left or right, notice I can follow along the curve to see which one I'm on, but I can also see which one I'm on up here. Is that one of the curves I want? So first curve, yep. Second curve, did it already switch to the other function? Yep. And then guess? I hate that language. It's not guessing. It's calculating it. Where's the intersect? 1, 0. You can use this to check answers. You can use this if it's unsolvable for you algebraically. I've not tried to solve this one, but I'll tell you, I'll give you something cool. I'll buy you a drink over at V's if you can come back. It's not V's anymore. Snack Jack. If you can solve this one and explain it to me, I'll buy you whatever you want over there within reason. $10 max. Okay, cool. We're not going to buy like the store. Okay, should we do another hard one? Here, or are we ready to do some board work? Cool. All right, I have one more board work. I have a worksheet for you that we'll do. Let's do one more ugly one. Okay, groups. Work with somebody you don't normally every day. Work with different people than you normally do. So if you always work with your sister or something, I want you to work with somebody else. If you always work with Aisha, I want you to work with somebody else. Spread the love. Cool. Go. Find a board. Find a new partner. Okay. This is not a calculator problem, just so you know. So you don't have to take them. You can grab them to check your answer when you're done. If anybody wants to write up here and talk out your process, you're welcome to write on this board. But I'm going to throw you guys a new one, and let's see what we get. Love it. All right. So this is example C if you're doing this in your notes. Here we go. I get 2 wonderful ones. Do you want fractions or decimals? Okay. I want you to solve, when is it true that 0.02x plus 0.03y is equal to 0.05. But hold on, I'm not done, because we also get negative point. You know what? I'm going to go crazy here. You guys said decimals, so I gave you decimals the first time. I'm cool with that. Negative x over 100 plus 4y over 100 equals 14 over 100. Cool. Solve this system. Check it with your calculator after the fact. Comment. I want you to pencils down, like eyes up. I don't really say that very often, but this one's important. Word problems are only hard if you make them hard. What makes word problems hard is the fact that you don't have an equation in front of you, right? Like that's always the hardest part. If you're working with 2 quantities that are varying with each other and we're trying to figure out how they interact, like all 4 of these problems that I've given you, the very first thing that I would do is I would have a physical statement written down, and I don't have a particular problem in front of me, but I would, bless you, that's not, I mean, I did, but that's not what I would do. My very first thing I would write on each problem after I've read through it is I would say, let x equal whatever it is, some quantity that you're going to represent with x's, and I would also write let y equal, so that right from the get-go, you've defined your variables, and now you can make sense of the equation. Like on our first one, I'm going to help you with this because we've not done just a bunch of these word problems. I'm going to put it up on the board, or I'll read it. You guys have it. 25 grand goes into 2 accounts. So some of my money goes into a higher risk account that earns 8.5% interest. What kind of interest? That means it doesn't compound. It's the same amount every year. Some amount of my interest, or some interest, oh my gosh, some percentage of my initial investment. It doesn't get more as I get more money. Okay, and what about my low risk account? 6.5. Okay, so let's just decide right now. What does x equal in this? So we'll read through still. If the total interest earned in the first 2 years, or over the first year, I'm sorry, is $2,000, how much money was invested into each account? Now, when I look at this, I would physically write this, and whether you can fill in the blanks or not, right now it's okay. Help me make sense of an equation that we could write down. How much money, how many accounts do we have? And if you were to add up all the money that went into each account, how much does it have to add up to? Not the interest I've earned, all the money that I invested. So if I were to take X and it was just the dollars in which account? Is this a 6.5 or 5.5%? 8.5, I'm sorry. Low or high risk? And I'm just picking, it doesn't matter. High. It leaves this for the dollars in what? Low. Now, if we pick these wrong from the get-go and then we can't write our equations, is it the end of the world? No, we don't lay down and stop eating and drinking and just be done. You just try something else. And that's okay to try something else. But if we can write our equations with these, this seems reasonable. If I were to take the money that I invested in the high and the money that I invested in the low, what do we know it is? Again, I want you to really carefully listen to this question. The money that I invested. How much money do I invest total? Read it again. I invest $25,000. If this is money that I invested in the high interest and money that I invested in the low, does it make sense that these two need to add up to 25,000? Okay. If I earn, let's see, X is high, and I would not remember this if I didn't physically write this, just so you know. Like, we need to write it so we know what we're talking about. How would I work out what, if X is the high, that's 8.5? Well, if I invested X dollars, what's 8.5% of it? Almost. 0.085. And that's times the money that I invested where? And I don't know that number, but what can we call it? Plus, well, what if I wanted the interest in Y? How would I find that? And now, everybody who's answered this question over and over, what should the interest on each add up to? Do we have, like, a couple things? This is obviously solvable, so I'm not going to ask the obvious yes or no answer. So notice, this is the money earned on interest, and this is the money invested. If we read that first one, what did we invest? Like the very first sentence of your problem. Well, earned, invested. And Addison, just to make sure, read me the very first sentence, or the first 5 words. Stop. If we didn't put X in one account and Y in the other, this should add up to 25,000. How much interest did I earn after 1 year? That's the last sentence. So here's 8.5 on the X investment, and this, it does work. Now, it's not the only way you could do it. This is the way that I see it. Is it hard once we decide what X and Y are? No. Is it hard? Like the first time it might have been that you might struggle to pick what X and Y are, but as long as you try one of the two things that are moving and changing, you're probably going to be okay. I want you guys to start working now. My hope is that we can bring this back completed tomorrow with the understanding that we have that 45-minute rule. If you are really struggling with it, it happens. When could you come talk to me before class? In the morning. I don't think anybody's going to have questions by the time the day ends unless you have study hall in another class, but I'm here after school if you do. Cool. If you struggle with the homework, it's okay. Stop by in the morning and talk to me, and I'll point you in the right direction before class. Cool, cool? All right. You got 8 minutes to work. You can probably solve 1 and maybe 2.